My name is Tim Probert and I'm the editor of Personal Care. Today's webinar is presented by Evonik. The title of today's webinar is Precision Cosmetics Redefined. Welcome to the new era of targeted skincare. In this webinar, you will learn how Evonik's R&D team has developed a delivery system that identifies its target and releases cosmetic actives exactly where they are needed most to provide outstanding anti-wrinkle and dermal regeneration efficacy at exceptionally low dosages. Today's presentation will be given by Juan Gonzalez and Christian Bellacanzoni. Juan Gonzalez is Evonik's Global Head of Marketing and Delivery Systems, specializing in nanotechnology and biology. With degrees in international marketing and economics, he has worked for more than 2 decades in the field of cosmetic active ingredients for B2B, but also in dealing B2C mass market and fast-moving consumer goods with technical sales and marketing manager roles. Dr. Christian Bellacanzoni is Evonik's Global Head of Applied Innovation in Delivery Systems, who specializes in nanotechnology and biology. With advanced degrees in molecular and industrial biotechnology and material science, Christian has led significant research and development initiatives in both academic and industrial settings. Christian is known for his visionary leadership in creating sustainable, biocompatible technologies for the cosmetics market, and he is also dedicated to mentoring future scientists as a lecturer and is an active contributor to scientific discourse. After the presentation, there will be a live Q&A session immediately afterwards. So if you see your chat in the box to what will be the right of your screen, there'll be a questions box. If you put your questions in there, Christian and Juan will answer them directly after the presentations. So over to you, Juan.
Okay, so so this is the presentation now. Okay, let's start. So I think everything works. So yeah, thank you and welcome everyone, and thank you for joining us today. So as Tim says, my name is Juan, and together with Dr. Bellacanzoni, so we are very excited to present to you X50 Neo-Core. So for us, X50 Neo-Core is a breakthrough in what we call precision cosmetics. So, and today we'll explore how target delivery systems can truly redefine efficacy in skincare, and as well as how we are addressing the earliest signs of aging with the science, innovation, and as well vision. So what's about precision cosmetics? Well, precision cosmetics is a vision, right? So, and the vision is pretty clear, right? So the idea is simple, yet powerful, to make active ingredients sustainably efficient, to maximize their potential, and as well at the same time to minimize unwanted side effects. That actually were our vision, and because the idea that I actually lied behind. So how to define, how to create a vectorized system, how to create something that was efficient in terms of potential, efficacy in cosmetics. So what you see is that in traditionally cosmetic actives ingredients, if used randomly across the skin. So this approach works to a certain extent, right? But it lacks control, right? So with vectorized systems, however, so we open a totally new chapter. For us, vectorization means that we work where precision, makes a difference. We work at the right place at the right time, right? So for us, precision makes totally the difference. So why? So it's because we can just speak of, what we see is our barriers to effectiveness, right? So cosmetic formulations and the barriers to effectiveness are pretty much related, right? So precision cosmetics is not easy, right? So every cosmetic formulation faces multiple biological and chemical barriers. So from the initial stability of the active to its ability to penetrate the skin, so what we call bioavailability. So it's very important for us to maintain the integrity of the active, but it's more important for the active to finally reach the exact site of action, right? So why? Because each barrier consumes a bit of the active and reduces its efficacy, right? So that's why classic formulations compensate by increasing concentrations, right? So, but for us, this is not the most sustainable way just to formulate, right? So our goal was and is to deliver more by using less. So, and to place the actives exactly where they're needed. So we did define, I mean, these 7 actually varies of to effectiveness, right? Because we knew that each barrier consume a bit of the active and reducing that efficacy. So for us to place the actives exactly where they're needed overcomes, right, this inefficiency of some classic formulations. So what is about, I mean, precision cosmetics and how we can redefine the efficacy through target delivery systems. So what are the main goals of any target delivery system? So first, of course, is precision, right? So a true target delivery system should achieve several things, right? The first thing is what I say, precision. So it must deliver the active precisely where it's needed at the right time and at the right moment. So protection is the second, right? We should preserve the integrity of the active, maximize the biological activity. So maximize the biological activity with lower dosages means that we have control on the bioefficacy. But the most important just for this system to be efficient is when we speak about safety. So for us, it's very, very important that we can reduce side effects by minimizing of targets exposure. So for us, ultimately, so it's all about turning control into efficacy, and efficacy into something that consumers, I mean, actually perceive. So into consumers' visible results. So this is the actually the target delivery system architecture, right? So let's look, I mean, how this architecture works. So first, the active ingredient is encapsulated, right? So this is the active ingredient and it's going to be released within the cells. And for us, it's very important that it's delivered intact, right? So we encapsulate it into a biocompatible, biodegradable polymer particle. And this protects the active and ensures a controlled release. So the last step, the first step, is on the particle surface. So it's a ligand a peptide that acts as a GPA signal, I mean, for everybody to understand. So this is like a guide system. So, I mean, this GPA signal guides the active directly to its cellular destination. So, and how once a particle reaches the target cell, so it binds to a specific receptors and it's internalized. So it's actually pretty much what when we speak about the whole mechanism. So it's all about, I mean, the architecture that is really well defined, I mean, from the very, very beginning. So different ligands means different target cells. This is where our innovation truly lies, because the ligand peptide acts just like GPS signals, as we said, and allows, I mean, active ingredients to navigate through the skin complexity and guiding them to the exact cells where they can perform best, right? So this level of precision is what allows us to as well create, I mean, highly efficient active ingredients for multiple needs in a skincare, right? What you see on the slide is that we use different ligands, so different peptides to target different cells, right? Depending on the type of cell we target, so we have a totally different cosmetic application. So this is what we call, I mean, or this approach, we call this approach the cosmetic drone. So this cosmetic drone, it's based on 2 ingredients always, right? One is encapsulated, one is outside as a ligand, right? So in our delivery system with targeting capabilities, so thinking of these as a guide system that penetrates the skin, binds specifically to the target cell, enter the cells and release the active. So, and these two different ingredients allows us as well to get different and multiple combinations, right? Because these are two peptides or two ingredients working in synergy, promoting on a specific pathway or application, right? So they can inhibit, same pathways or different pathways at the same time. So they can just work and in an opposite way, inhibiting or promoting. So this is actually one of the benefits of this architecture, is that actually so with one single system, so we can just, target different cells, but as well, so totally different cosmetic applications. So this is not only innovative, it's very transformative because it brings together so science, biotechnology, and cosmetics into a single mechanism of action that for us, consumers can actually see and actually feel. So this is where the innovation lies and the mechanism of action. So the basics, right? So, this skin penetration, and this is all the bioavailability. So this is how the mechanism of action works from the skin penetration actually to the cell targeting or the binding from the ligand to different receptors, the internalization at the end, so the release of the active. Don't forget that this active is being protected into a polymer and is going to be delivered and released intact to the cells. So maximizing the efficiency of the system with a very, very low dosage, because the product, actually the ingredient, is going to work exactly what it's needed. And one of the breakthroughs for us is to demonstrate actually so that the technology works. Because, you can see in this video, so how we can just prove with a confocal microscopy in real data. This is not only an animation, this is something that actually comes from the confocal data, and it's real. And what we can see here is that in 5 hours, so they are particles internalized into the cells, into the fibroblasts. And when it goes, actually we wait for 17 hours, we saw that most of the particles were actually internalized within fibroblasts. So that it demonstrates our technology that we can see, with the device, with a microscopy, that actually our particles indeed internalize into cells and deliver the actives, where are needed eventually. So this is actually so the value of the cell targeting at a glance with, this type of technology. So why X15-eosinocol? Let's start about, speaking about the product. So why in X15-eosinocol and why fibroblast? First because it's, so the most profitable market in anti-aging. So what we say is that, when we speak about anti-aging, anti-wrinkles is the main concern, but not wrinkles, but as well so the loss of firmness. Loss of firmness and wrinkles are among the most visible and emotionally loaded signs of aging. So that wrinkles are forming the dermis where fibroblasts live. So these cells are the architects of the skin structure, and they are responsible for producing collagen and elastin and other extracellular protein, matrix proteins. And we know that as we age, so fibroblasts slow down, collagen degrades, and wrinkles appear. So for us, targeting fibroblasts directly is the most effective way to restore firmness and actually elasticity. So what's the efficacy circle? So we actually designed an efficacy circle for X15-eosinocol. So the main purpose for this circle is for you to understand how we unravel peptide potential with target delivery through skin and into cells with clinical efficacy. So this is actually where X15-eosinocol comes into play, right? So that inside each vectorized particle, So we combine two powerful peptides. One is a cyanopeptide that stimulates collagen synthesis, and we have as well a carrier peptide and enhances cell communication. So that encapsulation ensures penetration down to the dermis where the fibroblasts are located, and the results. So we have a synergistic effect that boosts the production of collagen and elastic fibers, leading to a firmer and a smoother and younger looking skin in vivo, right? So this is our efficacy circle, something that actually it's being formulated, applied to the skin, and finally, leading to, visible, firmer, smoother, and you're looking, skin, visible results. And now I have the pleasure to hand it over to, Christian, and he'll explain actually all the experimentals, all the studies that we carried out just to demonstrate the mechanism of action of the system, but as well the efficacy, the experimental efficacy of X15 eosinocool. So thank you, Christian.
Thank you very much, Joanna. So let's dig more into the different study that we have performed on the X15 eosinocool and see more in details how it works and its efficacy. So because for this product, as Joanna was mentioned, we have a technology that we claim is specifically targeting fibroblasts. So for us, the first step is to prove such a mechanism of action. So the first test that we performed was the penetration study. Here we compared the penetration of the X15 eosinocool to the two peptide, the ligand peptide and the encapsulated peptide 3. And it's important to highlight that this test was performed in vivo in a volunteer, so we are observing the real behavior of our product of the X15 eosinocool in the real conditions. The penetration was followed by Raman spectroscopy, and here we can see that after 1 hour, the X15 eosinocool already started to penetrate into the stratum corneum, while the two peptides are not penetrating yet. And after 8 hours, actually we can see that while the two peptides are not able to penetrate deeper than the stratum corneum, the X15 eosinocool is penetrating deeper in the epidermis. So with this test, we were confirming that the X15 eosinocool is able to deliver the peptides in the inner part of the epidermis, and so reaching the fibroblast at the fibroblast keratinocyte junction. And this is a very important proof also, considering that we were comparing the X15 eosinocool to the 2,3 peptide, proving that actually the 2,3 peptide doesn't show the same rate of penetration. Then the second test that we performed to prove the mechanism of action is related to the actual affinity of the ligand peptide for receptors of the fibroblast. So we performed such tests. Next slide, please, John. And we were proving that, the next is the cell selectivity. So here what we were testing, we were proving that actually the X15 eosinocool can selectively be internalized by fibroblasts. And we performed this study comparing the fibroblasts to the keratinocyte. Here it's important to highlight that we perform such a study in a co-culture condition. So this means that the equal amount of fibroblasts and the keratinocyte, the equal number of cells were mixed together and incubated with the X15 eosinocool. We compare the activity of the X15 eosinocool to an X50 without targeting the peptide on the surface. So what we can observe, looking into the fibroblast graph, we can see that actually the X15 eosinocool was internalized preferentially by fibroblasts and in higher concentration compared to the non-target X50. And this means that actually the presence of a peptide, a targeting peptide on the surface of the particles, enhance the internalization of the particles compared to no target X50. But the most important part is the comparison with the keratinocyte. And here we can see that actually the X50 neosinocol was internalized preferentially in fibroblast compared to the keratinocyte. And this, by this test, we were proving that actually the X50 neosinocol can specifically target the fibroblast, and we can observe that all the results that we were obtaining here are actually statistically significant, so we can affirm that the X50 neosinocol show selectivity for the fibroblast. Then, as I was mentioned before, the next test was to actually prove such affinity of the targeting peptide for the specific receptor. So we performed a binding assay very quickly. I explain you the test. So we have a receptor, the partial receptor immobilized in the substrate, and then we have a specific ligand, radiolabeled ligand for such a receptor. Then we add our ligand peptide, and we evaluate the amount of ligand peptide that is necessary to displace the radiolabeled ligand, and so to show the affinity to the receptor. And actually, we can see that we were observing a very good affinity for such a receptor by the ligand peptide, and we can see that also we were having a dose depending affinity, increasing the concentration of the ligand peptide, we were obtaining higher affinity. So overall, with this test, we were demonstrating that actually the ligand peptide, that in our case is the palmitoyl pentapeptide 4, show a affinity for the partial receptor. Next slide, John. Then the final study for the mechanism of action was to prove the actual internalization of the X50 neosinocol into the fibroblast, and also we were using in this case the confocal microscopy to have a visualization of such internalization. And there, here we can see that actually the X50 neosinocol, which are these red sphere that we can see, are internalized into the fibroblast after incubation for 5 hours, and the amount of particle internalized increase with the time of incubation. So overnight we were observing much more particle into the fibroblast. And here is worth to mention that actually these are the images, confocal microscopy images, that were used then to reconstruct the 3D video that we have shown at the beginning. So once we prove the mechanism of action for the X50 neosinocol, we move to prove the efficacy of the product. So we run in vitro test, ex vivo test, and finally clinical tests to prove the efficacy of the X50 neosinocol. Next slide, John, please. So the first test that we performed was an in vitro test to demonstrate, to study how the X50 neosinocol was able to control the expression of different genes. We were testing collagen 1, collagen 3, fibronectin, and elastin, and we were comparing the X50 neosinocol to the two free peptides, so to the encapsulated peptide, the copper peptide 1, and the ligand peptide, palmitoyl pentapeptide 1. And we can see that actually when the fibroblasts are incubated with the X50 neosinocol, we were able to observe a strong increase in the gene expression of these 4 studied genes. And we can actually see that the two free peptides were not able to induce any change in the expression of such gene. We can see that the X50 neosinocol has a very strong promotion on the gene expression, and this such promotion is statistically significant compared to the free peptide and to the untreated control. Then we move we perform an in vitro study evaluating the amount of protein produced in the fibroblast. Next slide, please, John. So in this case, we were studying by ELISA the amount of procollagen 1 and fibronectin produced in the fibroblast. We were performing the study with a similar condition, so comparing the X15 eosinophil to the 2-free peptide. And here we can see that actually in both cases, the X15 eosinophil was again able to induce an higher production of the 2 protein. In particular, in the case of the collagen 1, we can see that we are having a higher production of the protein compared to the 2-free peptide, and this increase in the production of protein is statistically significant. Once we prove the efficacy in vitro of the X15 eosinophil, we performed the ex vivo study. So next slide, please, John. In this case, we were using human skin explant. The donor was a Caucasian female with the age of 46, and we were studying by immunostaining different markers. The first marker was the collagen 1. In these images, we can see the fluorescence microscopy images coming from the skin, where the red refer to the staining of the collagen, and in blue we can see the cell nuclei. And we were comparing the X15 eosinophil to the free peptide. In this case, we were using a mixture of the free peptide, but here it's worth to mention that the X15 eosinophil was tested at 10 times lower concentration compared to the free peptide. So the skin explant were exposed to the X15 eosinophil or to the peptide mixture for 3 days, and then we analyze the amount of collagen produced, and we can see from the graph on the right that the X15 eosinophil was able to increase the amount of collagen 1 produced by 60%, and this increase was statistically significant compared to the free peptide. So also in this case, in ex vivo tests, we were able to demonstrate the higher efficacy of the X15 eosinophil compared to the free peptide. We then studied second marker, which was the elastin. So we were also in this case using the human skin explant, but evaluating the amount of elastin produced. Next slide, please, Joan. So here in the fluorescence microscopy images, you can see that these times in red is the red signal is coming from the immunostaining of the elastin fiber, while in blue you have the cell nuclei. And again, also in this case, the X15 eosinophil was tested at 10 times lower concentration compared to the free peptide. And in this case, we were observing even a much stronger efficacy on stimulating the production of elastin. We can see that the X15 eosinophil induced an increase in elastin production of 68% compared to the free peptide. So this study as well was demonstrating the very high efficacy of the X15 eosinophil compared to the free peptide. And once we finalize this in vitro and ex vivo study, we move to the clinical study. I will hand over to Joan for introduce you the results obtained by this study. Thanks, Joan.
Thank you very much, Christian. Very nice. I mean, so let's speak of clinical studies. Usually is what I mean all customers usually they are expecting. So how these active ingredients turns into a visible, formulation, right? And as well so to visible results on consumers. So the clinical study, evaluated the anti-aging efficacy of 1% excipients eosinophil in a randomized, double-blind hemiphase application. I think it's very important, it's worth to mention that this 1% is 1%, 0.001% of the active content, right? So, I mean, we formulate at 1% of 1 gram per liter of the active. So with that means that how efficient we are in terms of, integrity, and how we can't just deliver the active within cells, intact, right? So this is, how we speak about precision. So, really, using a very, or extremely very low dosage of active ingredient, and achieve visible results. So this clinical study was carried out with 30 females, with mixed phototypes, based on the skin aging atlas, with the score 2 and 4. So that means mild and moderate facet wrinkles. So the average age of these volunteers was, 51 years old, from 38 to maximum 58 years old. So excipients was formulated in an oil water cream and then applied twice daily after cleansing for 60 days of continuous use. We had 3 different controls, starting at day 0, 4 weeks, and as well the latest control was 60 days, so 2 months. So we did carried out many different types of the studies just to assess wrinkle effect, anti-wrinkle effect, firmness and elasticity, and dermal density. All of them, they are related, to dermal architecture and how, and the ability of excipients eosinophil, to promote the extracellular matrix proteins and increase, these dermal architecture to improve dermal, density, and then so more firmness, more elasticity, and finally less wrinkles. This is a summary of the results because we just go to the data and the graphs, but I think the most important, what matters in cosmetic science is not having one spectacular responder, but actually showing that the active ingredient works consistently across people. In this study, even with 30 subjects, right? So we did demonstrate a statistically significant improvement versus placebo, and as well versus vehicle, which is actually the gold standard for proven efficacy. So this means that the improvement, right, we observe is not due to chance, not just because of the base cream, right? It's a real effect of the ingredient itself. And then, so when we talk about significance, so we are talking about reproducibility and reliability, which are far more valuable than one single eye-catching number. So I think this is the most important in this slide, is that, X50 versus baseline vehicle, it was significant in all attributes, in all mark, controls, in all actually the parameters, from the glutometry that we check, skin firmness and elasticity, plus what at the end is in hydration, right? Wrinkle score with BC and primers, 2 different techniques that evaluate or assess, the wrinkle, anti-wrinkle efficacy, but as well, so, the dermal density, so with ultrasounds. I insist that we talk about significance of this study, right? Both, versus vehicle and the baseline. And we talk all about reproducibility and reliability. And what is far more valuable than what I mentioned, any single catching number. So with the glutometry and the skin firmness and elasticity, so these are changes from the baseline. So, considering that we have 30 subjects, right? So it was very important to understand, so what was the initial condition, right? Of, all volunteers independently, right? So that would be used baseline as a control, right? The numbers are very solid, and because they are significant, So what we get is this improved firmness of 12% and elasticity by 30%. But as well, so what we have is an anti-wrinkle effect that from the baseline. So we have a reduction from the baseline in both techniques using VCR and as well using primers. So, I mean, VCR, for you to understand, is excellent when you see, I mean, visible colors, when you see actually, so what are the visible results, you know, from the day zero, and you can compare, I mean, after 2 months, I mean, you see visible, real visible effects. But this is a two-dimension techniques. What you see is a real picture of the volunteer. But primers provides a lot of information because primers is the image analysis. It's like, I mean, topography. So you can just, I mean, assess and check, I mean, different variations of the wrinkle, right, at different levels and depths, right? So that's why primers for us is a three-dimensional image analysis that provides a lot of information about what is happening, right? I mean, and what's not visible. So the combination of VCR and primers, I mean, provides us a lot of information about, I mean, how this anti-wrinkle effect, right? I mean, it turns into something visible. You know, what you see is that, I mean, using VCR and using primers as well, so we have a significant reduction of the wrinkles, I mean, in only 60 days. So this is one of the anti-wrinkle efficacy, what you see in the volunteer number 37, right? This is a single eye-catching number, I know, but actually what you see here is actually perceivable, visible change from the baseline using X15 eosinophil. Remember that the concentration of use of the active content was 0.001%, right? And that is what, I mean, makes so the system so efficient. And these are the visible results after 16 days with that level of concentration or active content. So what you see is clearly, so what is the evolution of the wrinkle, I mean, in only 2 months. And it's actually spectacular. But I think it's much better if we go to the primers images and we check as well, so the day 30 and day 60. And what we see, you know, the darker colors, I mean, actually means, I mean, the wrinkles or areas where they are really, really, I mean, depressions right deep, you know, on the skin. So what we don't see, you know, in this year is these areas that they are bluish, right? They appear, right, like blue. This is very difficult to see, you know, as with a naked eye. And this proves from primers and this three-dimensional image analysis that it's not only wrinkles. I mean, actually, so the skin texture is much better, right? So it's firmer, and this comes actually from, you know, beneath, right? So this is actually how, I mean, dermal density and all these extracellular matrix protein synthesis, you know, are located, synthesizes and push, you know, the skin up from within, right? These primers images are actually as well spectacular because they define so what is actually so the actually efficacy in terms of, I mean, firmness, in terms of dermal density, that they are very difficult to see, you know, I mean, if it's only, you know, an image, you know, showing visible, I mean, results, I mean, of wrinkles. And this is the third actually technique we use to prove that the consistency of this efficacy of this, or the solidity of this efficacy is the dermal density. So dermal density as well, so from the baseline, right, is statistically significant, you know, baseline versus vehicle, you know, and what we see is that, I mean, in these, I mean, white color is how dense the dermis become, I mean, in only 60 days. This is the result of the extracellular matrix protein synthesis that they are actually liberated on the dermis once they are synthesized by fibroblasts, and they are activated, of course, and they synthesize, these proteins. So the more proteins we have, so the more density, because this is how ultrasound works. Just trying to, send signals, so send sounds, my ultrasounds to the dermis, and just get the answer back, right? And what you see is that the more dense, so the more white, right? So the more, you get the answer, the answer faster. And that is what, it's reflected, it's shown on, this type of images. So the combination of this thermal density that is originated by the synthesis of extracellular matrix from X15 eosinophil. So it means that you had a better firmness and a better elasticity, and eventually, so the result is visible, and it's the anti-wrinkle effect. So that's what it goes. After the clinical study, so the perceived efficacy. So numbers are powerful, but actually, so consumer feedback is even more telling. Over 90% of volunteers noticed their skin was more hydrated. And this is as well a consequence of this dermal architecture improvement, right? So more than 80% of the subjects as well, so would recommend the product, and an equal number would buy it. So this shows that the innovation doesn't only work in the lab, right? For us, it resonates in the real life. So where consumer actually make their choices. So this is a composition on product data. What you see in the ink name is pretty neat, right? It's pretty clear. So we have peptides, two peptides. You have the composition of the polymer, the PLGA polymer. So the product is very easy to formulate, easily, like, preservative systems and all other active ingredients are actually incorporated at the end of the formulation below 40 degrees, right? And it's very, very easy to formulate, because as well, so the range of pH is really wide, so it can be incorporated in many different types of formulations, regardless of the pH. So the product is China compliant, and this is important because this is the one and only China compliant target delivery system. So there is no other target delivery system that is approved, in China. And this made us really, really happy just to develop something that was so critical as well for, for the global markets. So the product is CFI certified, and we expect just to get halal certification, so by the end of this year. So what should you take, home today, right? So that X15 eosinophil is a unique and proven combination of synergistic peptides encapsulated and delivered directly into fibroblast intact. So it's precision driven. It's a science-backed solution that delivers powerful anti-wrinkle and dermal regeneration performance at extremely low dosages. For us, it's ideal for high-performance skincare brands that want to tell the story of a cutting-edge science, so clean beauty, visible efficacy, and as well, so why not? Using the cosmetic brown just to translate to the technology into consumers. And for us, this is not really just another cosmetic active ingredient. So for us, we have achieved what we call precision. So for us, it's precision cosmetics in action. So thank you very much for your attention. So actually, so these are, our emails. You can reach us at any time. In case of there is later on, after the webinar, there are questions still, to be answered. And we hope, on behalf of Christian Bellacanzone and on, you know, and I. So we hope that this presentation that has inspired you about the possibilities of precision cosmetics, the power of target delivery systems, and we are actually excited, you know, about the opportunities ahead, and we look forward, you know, I mean, just to bring this innovation to life in many different formulations. So thank you very much for your attention.
Thank you very much indeed, Juan and Christian. So we've had lots of questions, which I'm delighted to see. We've got about 15 minutes. So if you do have any more questions, please put them in the box, but we have got lots to get through. So there's a couple of ones about samples and the slides of your presentation. We've got the email addresses there. If people are interested in wanting samples or your slides, presumably they can just write you an email and you can take it offline and do it that way. And presumably that's okay.
Yeah, for sure. Yeah.
In terms of the email address, there's a bit of a disparity. Is it JUAN that your email address, or is it JOAN?
That's correct. Yeah, that's JUAN. Yeah.
GUAN. Okay, good. All right.
Yeah.
Question from Anatella: has the technology been tested on scalp care applications as well? Scalp care, has it been tested on the scalp?
Christian? Wasn't sure if well, it has, yeah, Christian, yes, go ahead, yeah, please.
Yeah, I mean, it's no, actually, this specific product has not been tested for scalp care. It's true that this is a very flexible technology platform. This means that we can functionalize the surface with a different targeting peptide, as Joan was mentioned, and is something that we are working on to develop also a specific product for a scalp care.
Okay, thank you. Anna asks, what is the particle size of your product? What is the particle size of the X50?
The particle size of this X50 is between 150 and 300 nanometers.
Yeah, I think we saw that. And another question, Anna, inky name, we saw the inky name, but what is the recommended usage in a formula? Is it 1%, wasn't it?
That's 1%. That 1%, that 1% contains, I mean, it's a solution of 1 gram per liter, right? So it's 1% of 1 gram per liter. That's equal to 0.001% of active content. That, I mean, for formulators, you get the solution, so it's 1%.
Okay, good, thank you. When using your product in cosmetics, are we still able to claim them to be cosmetics, or do we need to register our product as a drug due to your particle's deep penetration?
Well, that's an excellent question. That, I mean, think that, for instance, so in the B2B context, so I mean, we are, of course, I mean, target delivery systems in cosmetics are simple, right? So blah blah blah. So the challenge was to design a carrier that was stable, safe, affordable, and effective, right? What would happen is that, so we are speaking of a chemical, right, in the concept of B2B. So when we translate this into cosmetics, so cosmetics, they follow regulations, for instance, in Europe, right? So there are certains, right? Certains, I mean, words or wording descriptions that they are not allowed, right? So we are speaking of targeting. We are speaking, even for many regulations, dermis is out of the cosmetics, right? So, I mean, what's important is that this ingredient was actually developed using active ingredients, cosmetic active ingredients under the cosmetic regulations. So it means that this product is not systemic, right? And is, you know, it follows, you know, most of the, or complies with most of the regulations. But speaking of labeling, it's a totally different context, right? So it's like, I mean, it's for our customers to, you know, to adapt, to adjust the wording and to the the text, right? So into, you know, the end product cosmetic regulation.
Okay, good. Thank you for answering that in depth. Were there any adverse reactions reported during the clinical studies?
No, we didn't observe any adverse reaction. Here also is worth to mention that we, for all our product and also for the X50 Neosinocolor, we provide to our customer very full detailed tox summary showing the safety of our product.
Okay, thank you. A few questions to do with, on the sustainability angle. So there's a question from Simona about, is there a Cosmos or Nature certified option? There's another question about Cosmos, and also, are the synthetic components derived from petrochemicals, or is it petrochemical free? Asked Alison. We could take those all together.
Yeah, I mean, it's obviously this is a synthetic product since we are using if it's proven biodegradable polymer, which is PFGA, that is FDA approved and it's widely used since decades in for pharmaceutical and biomedicine application. But it's true that it's a synthetic polymer, and also the peptide as well are synthetic. So overall, for these cases, it's not possible to have such a certification.
Okay. Another question: how long does the treatment last? If we stop using your product, will the positive results achieved earlier stay permanently, or must the consumers keep using the product?
And that's how cosmetic works, right? And the business works. I mean, actually, so this is so easily, it's a very good question, right? Mm-hmm. But this is how it works. I mean, you know, if the results were permanent, right? So I mean, the business, I mean, will end quickly, right? So, I mean, what is important is that, I mean, we achieve, right? So I mean, that level of efficacy, especially because it's worth to mention that, I mean, our main goal was, I mean, to promote, to synthesize collagen 1. That's why, so you get 60 days, because collagen 1 is I mean, actually a very difficult protein to synthesize, right? It's much bigger to collagen 3, right? And it needs longer periods of, you know, duration or time. I mean, just to be synthesized and be located in the dermis, right? So, but of course, you know, I mean, if you age, you know, your dermis slow down. So the thing is that what's important to understand is that this is something that we need, you know, when, I mean, our skin slow down and needs some, you know, dermal regeneration. But of course, I mean, if you quit using the product, you know, we never know, you know, we never know, because it's actually the duration it's been 2 months. Yeah.
Okay. So, okay, thank you. Okay, next question from Silla. How is X50 activating directly the fibroblast cells if it arrives only to the viable epidermis and not in the dermis?
Yeah, this is a very good question. Well, let's first of all remember that the penetration test that we performed was performed, the time was 8 hours, and this is due to a limitation of the techniques itself, because after 8 hours it started to be, let's say, diluted the signal, and the particle cannot be tracked anymore. So this means that we have seen after 8 hours a very significant penetration up to the deeper part of the epidermis, and probably this penetration will follow in the next hour up to the dermis epidermis junction, and that is where we will have the interaction of our X50 Neosinocolor with the fibroblast. And also the ex vivo study, where we were actually observing the effect of the X50 neosinocoll on promoting the production of elastin and collagen one confirmed that effectively the X50 neosinocoll reached the fibroblast, and that study was demonstrating that the free peptide were not able to have the same efficacy. So with this indirect test, we can confirm that actually the particle reached the fibroblasts.
Thank you, Christian. A question from Gabriella. Are both hydrophilic and lipophilic actives loaded in the nanoparticles, or both? Can both hydrophilic and lipophilic actives be loaded in the nanoparticles?
Yeah, this is a very good question, and actually our PLJ particles are very flexible from this point of view. So we have already experienced with a different X50 product where we were able to encapsulate both lipophilic and hydrophilic active.
Okay, thank you, Christian. Sorry.
One thing to mention, Tim, is like, I mean, the questions. So these are not nanoparticles, right? They don't fall into nanoparticle category under the European regulation, right? Because of the, the range of, particle size is over 100, right? So it's like, we cannot just refer, according to the regulation, to, nanoparticles for this product.
Sure.
I think it's worth to mention, right? Because even if we speak about nanometers, so the product, it doesn't fall into nanomaterial category.
Sure, worth pointing out. Question from Senya. Have you tested the ability of the delivery system to unintentionally bring in other cosmetic ingredients into the skin? Have you tested the ability of the delivery system to unintentionally bring in other cosmetic ingredients into the skin?
Well, very interesting question. And we don't have a specific study on if actually these particles are able to bring other actives. It's true that we design and we produce such particle loading the inner part with the higher concentration of the active possible. This means that actually physically there is no space inside the particle for other active to be encapsulating. And by the way, once you have the final structure of the particles with also the stabilizer on the outer layer, it's very difficult to other molecule and ingredient to be absorbed or encapsulated into the particle. So it's very unlikely that this would happen, but it's true that we don't have such study characterization to effectively see if it's possible or not.
Okay, all right, okay. We've got a couple minutes left. We've got a few more questions, so just rattling through them very quickly. Is X50 safe for pregnant and breastfeeding women?
Well, as I mentioned, we have our full tox summary proving the safety of these particles, and there is also this specific section and from the component and the evaluation, the assessment of our toxicological teams. There is no risk, but we always provide the tox summary so the customer can actually prove the specific claims and the safety for the product.
Okay, thank you. Richard asks, is X50 heat sensitive? Is it heat sensitive?
Heat sensitive? Yes, actually, our the formulation heat that we provide with this product, we suggest to incorporate in the final formulation in a cool down process at temperature lower than 40 degrees. This is worth to mention that the incorporation of this ingredient, it's very easy. You don't need harsh condition. You don't need very high energy homogenization is very easy to incorporate, and yes, it's temperature sensitive, so we recommend to incorporate in the cool-down process.
Okay, thank you. Richard again asked about the Philippines and getting samples. So again, as mentioned, if you have those sort of the demand requests, then Juan will only be too happy to answer such samples and slides and any other questions about the products. He just fire him in. I'll be very happy to help you out. Okay, well that's all we have time for. That's an hour. Just like to say thank you very much to Juan and Christian for your fascinating presentation on some very cutting-edge cosmetic chemistry. If anyone has joined us halfway through and like to see the entire presentation, we will be sending out the entire presentation via email this week with a link to the whole presentation. As mentioned, if you want the slides, just get in touch with the guys here. Thank you very much for joining us today. Thank you, chaps. Thank you.
Thank you. Been a pleasure.
Bye-bye.
Thank you very much.
Bye-bye. Bye.